Welcome to the Trend Detection Podcast, powered by Siemens.
Thank you very much. I'm on. I'm Simon Kampa. I run the Senseye business within Siemens. Actually, Senseye was a company that was acquired by Siemens over a year ago, and now we're kind of part of the Siemens family. The aim of today is I'd like to share our experiences on how to successfully deploy predictive maintenance to reduce unplanned downtime. And I'm putting to reduce unplanned downtime in brackets for a reason, because often, as we'll find out, often the reason for doing predictive maintenance may not be for the downtime. You may have other issues that actually give you a better, stronger business case. So in exchange for me sharing our experiences that go back over 10 years, I will now again plug the Senseye product, but not much. Most of it will be on our experiences. And just to be clear, Senseye is a cloud-based AI predictive maintenance tool that helps you reduce unplanned downtime, helps you meet your sustainability targets, helps you reduce your spares, etc. And that's Senseye, right? So I'm going to show you a little bit about Senseye later, but mainly it's about our lessons learned. Here's a quote you'll get from many sources. Just Google it and you'll get that quote. 4 in 5, so 80% of industrial IoT type projects, including predictive maintenance, are considered a failure. They don't scale, you do a pilot, you don't get a business case out of it. And there's lots of reasons why they fail, but often it's they can't scale, technology doesn't work, and there's no business outcomes, right? So today, the essence of today is why. Why do so many of these deployments fail? And you may have tried predictive maintenance in your own site or installation, and maybe it's failed as well, and you'll have your thoughts on why it failed. But 80% failure rate is high, okay? And I'm going to use a product that we have, a sister product that we have as a platform to go through those lessons and experiences and failures, why they happen. And then the key message to take away from today is you've got to consider predictive maintenance as a journey of change. It is not a technology. You're not buying a PLC and dropping it into the factory floor, right? It is a change. You're buying change. Change takes effort, it takes momentum, it takes people to change. It's not just technology. So we have this Senseye knowledge platform, if you like. It's a deployment methodology. I like to think of it as 8 years of failure, because these are all the things we've learned over 8 years of making mistakes. So we captured that in a deployment methodology, all the way from starting the deployment, the pilot, to scaling it to global sites. And each step we've learned is, if we follow that step correctly, we will have a successful project at the end. In very simple simple terms, the overall deployment methodology starts with what you're going to do, how you're going to do it, start doing it, use it, and then scale it. Right? Those are the simple steps. And I'll talk about each step, and then talk about why there are certain failures that might happen during that step. So the first one, and you kind of look at it and think, this is so obvious, why don't people do it? But you need to define what you're doing and why you're doing it. So many predictive maintenance projects are done because it's cool, because your competitors are doing it, because everybody's talking about AI. Right? That's not a good reason to do it. And we've had, in the past, several pilot projects which are a technical success, but they don't achieve any business outcomes. They don't work for some reason. So, one of the key things that we've done, and we've only been doing this for this stage for 2 years, so it took us time to learn it as well, is the key outcome of this is to work with the customer to really understand what it is that we hope to achieve, what business outcomes, where's the ROI, right? Because often you might think downtime is an issue for you, and then we do a pilot, no machines fail, you don't get a business outcome. So we work with them to work out what machines, when they do fail, cost you the most downtime. Maybe downtime isn't an issue. Maybe your issue is you're doing over-maintenance. Maybe your issue is you're ordering too many spare parts. Maybe your lubrication schedule is too aggressive. You're doing it too often. So we look at all those areas and work out what's the biggest pain point within your site, right? And how can predictive maintenance then solve that? And the end of this whole scope basically is an alignment between us and the customer on what we're looking to achieve and what the expected ROI is. And then maybe there is no ROI. Maybe actually you think you've got a problem, but when you look at it, the ROI isn't that great, and it may be cheaper just to buy a hot standby or another person on it, right? So it's really important that we do this scope phase to really understand what you're doing and why you're doing it. And it may sound so obvious, right? But so many projects start without doing that. And if you start without doing that, key reasons for failure is, and I mentioned these already, right? You don't know what you're buying. We've had this so often that a customer doesn't actually appreciate what you're buying, but because everybody's talking about predictive maintenance, it's such a hyped up concept, you feel you've got to do it. So you don't know what you're buying, and if you treat it as a technology, not change, if you treat it as a technology and just drop it to your maintenance team to use it, they won't use it. It won't work. So you need to set up the project in the right way, make sure that you've got that strategic sponsorship from yourselves and your team, and you know what you're doing to achieve. Now, the next stage, so you've done the scope, you understand why you're doing predictive maintenance, and it's not because it's cool. The next stage is probably the most important, along with the one after that, is you've got to try, so you're going to try predictive maintenance, where are you going to do it? Right? Now, the worst answers are, and we get this a lot, is we'd like to try it on our new shiny machine, because it's all connected already, that's great. You'll probably prove nothing with a new shiny machine, because it won't fail. And second one is, okay, can we try this on 2 or 3 machines? No. What will you prove 2 or 3 machines? Unless you've got really poorly behaving machines, they're not going to fail, you're not going to get much of a business outcome. Right? So we always say, you've got to start with a good scope of machines that have a genuine problem. Right? So that's a really key thing. Once you've understood the machines that you want to use as part of your initial deployment or pilot, then you've got to say, okay, what data is available that we can use to expose the health of those machines, to expose the data on those machines. And then you obviously do the IT/OT integration, right? So those are the steps that we do. And often it's amazing how steps 1 and 2 are kind of ignored. You just connect your new machine, or you just connect 2 or 3 machines and say, hey, let's see what happens. It'll fail. So get it right. This is a very dummies diagram. You'll appreciate this probably from yourselves. Most predictive maintenance solutions are cloud-based, just because of the sheer power of AI that's required in the cloud. There are some on-premise solutions, but they tend to be more kind of condition monitoring solutions. But the general data flow is, you've got your machines, you get data out of the machines, it goes to an edge device or a line PC to do some pre-processing and washing of the data, and then you send it through the gateway to the cloud. So there's a key issue here, is obviously you've got to talk to your IT guys to make sure that, first of all, cloud is okay, and sending some of your data from the machines to the cloud is also okay. So what happens at this stage, in our experience, has led to failure, right? Apart from selecting the wrong machines. Often, we get this a lot, customers say, hey, you've got loads of data. And it's all inappropriate. It's got to be the right data to expose the health of that machine. You kind of say, well, we've got some vibration data, let's use that. If that vibration data doesn't expose the health of the machine, it's no use using it, it'll fail. Right? So you've got to be really key to make sure you've got the right data before you start. Not using the pilot to test if you've got the right data. Often, products require you to install their own hardware, their own sensors. Maybe they require you to buy new high-fidelity sensors to work with that. And then that can then be, okay, that's just too expensive for us to do, so the project fails. It's not cost-effective to do that deployment at that scale. Another key thing is, we all know factory environments are really noisy, they're chaotic, they're dirty at times, right? And are often things that look like they're going wrong, that's just normal business, right? So there's a lot of XOI called contextual data that we can use, maintenance events, for example, that can help enrich that data and make us understand better why a machine is behaving in a certain way. Okay. And then obviously IT integration challenges are always a challenge. And for us as a company, before we joined Siemens, that was a big challenge because that's not our gift. Siemens obviously has great experience and products to take the data from the machine all the way to the cloud. Now, a little bit of again a plug for Senseye's solution, if you like. How do we mitigate some of those issues? So one is that we don't require customers to install new sensors or hardware. Sometimes you might have the old machine that needs some retrofitting, but generally we use the data that's already existing on the shop floor. That might be in drives, it may be in PLCs, it may be a sensor, it may be from your process management system. And the key thing here is to get going for it to reuse the data that's already on your shop floor that we're invested in and bring that to the cloud, to Senseye. And the second thing that we I think we're the only product on the market that actually fuses not just taking machine data, but combines that with maintenance data and the expert knowledge of the maintenance person. And that's really key. And you'll see later when I talk about how you prevent over-alerting. That's a key thing that we do to help make that data pool available to our analytics more enriched. Okay, so we've scoped the project, we've designed it, or decided what assets we need, and we decide how we're going to do the IT/OT integration. The next step is we deploy it. This is probably the easiest step, assuming you've done the first two stages correctly, because they just execute. It's install any hardware if you need to, get the gateways opened up, and get the right data in. So things that go wrong here are if you've not done the design correctly and you've got the wrong data going into the system, it's going to fail. Or obviously our good friends in IT, we've engaged them too late and they're not very happy about us sending data to the cloud. Right? So again, if you do the first two stages correctly, the third stage of deploying it is just execution. Right? It shouldn't be. But often at this stage, you get all the issues if you've not done your homework before then. Okay? Now, operate phase, I would say, is the most important phase. So that's using it. Right? And the common solution may be, there you go, here's a technology, please use it. What I said at the beginning is, you cannot view predictive maintenance as a technology. It's a journey of change. It's change management you're basically buying. You're asking people to change the way they do their maintenance activities. You're asking them to be more proactive. You're asking them to take extra time to use a system that can alert them in advance. And we found that if you just drop the technology into the shop floor, every single time it will fail. Right? We all know maintenance staff are incredibly busy, incredibly chaotic at times because you've got so many things going on, and a little bit cynical as well, especially to all this hype of new technology. Right? So it's key that you and what we do in the early days to mitigate this is we shadow our customers with our own condition monitoring engineers to make sure they're using the system correctly. Are they responding to alerts in a timely manner? If the system's not working properly, can we intervene at an earlier stage? And obviously a key part also is that it's got to be a really easy to use system. If you just show a bunch of graphs at them, they don't know what to do with them. Most maintenance engineers are averagely skilled, they're not reliability engineers. And I'm just going to show you our workflow of the tool. And our whole aim is to keep it as simple as possible. And I'm just going to show you the very typical workflow, probably 5% of the whole capability of Senseye. So just a little bit of it. And it's a cloud-based application, so you can use it on your PC, your tablet, your phone, whatever you do. And the key way you navigate around our system is around the asset hierarchy, we call it. So that's how you visualize all the machines in your factory, right? So typically, this is, I think, an example of a food and beverage company, right? You've got the different sections of the line, and then you might have, within the packaging, you might have line one. Within line one, you've got the various other stations and machines, and then within that, you've got the machines. So that's how you navigate around. It's basically the way you view your machines in your factory. The second thing we do is we raise what we call cases. These are like alerts, basically. For any machine that's not that we are worried about, that we think is going to cause an issue, we ask you to interfere with that. And when I say color-coded, you can see up here as well, you can see the color coding as well, so you can very quickly see where a machine is showing a problem. And then the last part of the navigation is these cases. So case is alerted to the maintenance person. So the way it would work is the maintenance person starts their shift normally, so most of our customers use it, and at the beginning of their 8-hour shift, they will open up Senseye. Are there any machines in my area that need attention because the system's worried about their performance? In this case, you can see there's two red ones. So what they would typically do, they would look at the case. And the case is, as I said, is our version of an alarm. The case gives you a bit of information, right? It'll give you a little bit of the history of the health of that machine. So that top line is the health of that machine over time. So maybe it's been a very healthy machine for years and now suddenly it's failed. Or in this case, it's had a bit of a potted history of issues happening with that machine. We might give you the reason why it's failing, what is the actual fault mode, and potentially the remedial actions that you want to do. You'll also notice that we give them one or two pieces of evidence that worry us the most. And this is a key differentiator because, as I said, in a factory environment, noisy environment, there's lots of things going on. If you just raise an alert every time something unusual happens, as you'll see, these are all the unusual activities. You get 100 alerts just for this one machine. So what we do is we only bring a case up, an alert up, and we're confident there is enough evidence that something's going wrong, and then we give them the one key bit of information that worries us the most. The more the bits about abnormal behavior that we spotted, that's the one that worries us the most. Now at this point, you can either just raise a work order, or most of our engineers, the users, would like to go deeper into the data. They don't have to, but some of them have a bit of background and they want to go deeper into the data, show me the actual sensor measures, and look at the past work events, etc. That's optional, but the system provides that. So at this point, the maintenance engineer would say, okay, I believe the system, we have an issue. So let's raise a work order to investigate. Now, you can either do the work order in your own maintenance management system. If you haven't got one, you can use our basic work order system there. And that's the usual sort of work order. You say, okay, I'm going to lubricate a bearing or whatever repair you're doing because of Senseye. And then you do the work order, and the last thing you do, really important, is you close the case. And this is really important for AI. You know, AI has a feedback loop, right? So at this point, you say, give a grading of, was a case raised for the right reasons or not? And then learns from that. So, for example, a common issue might be morning, when you start your machines in the morning, the oil is a bit thicker, there's a spike in current in various measures. That's normal. You have to be alerted for that. So if you get alerted by that, you keep saying, no, that's rubbish, we don't need that, you'll learn that that kind of behavior is actually expected and suppress any alerts. So really key. Okay. Now, so that's the operate phase. And I just gave an example of what I think is a quite intuitive, simple user experience to make sure those the maintenance engineers will adopt it. But the key reason for failure at this point, and it's probably one of the number one reasons for predictive maintenance kind of having a bad reputation, like I said, 80% failing, it's a low adoption rate because you're dropping the technology in and nobody wants to use it, doesn't understand why you're using it, doesn't understand what business benefits you've got. And often the tool is too complex to use. So over alerting is another common issue with predictive maintenance. And during this time as well, if you're not doing your homework properly before us and understanding why the hell we're doing this project, often at this point you realize there's no business outcomes. I'm using this tool to monitor my 10 robots. No robots have failed in 6 months, so what's the system telling me? Nothing. Right? So that's another common reason that during this pilot stage, you realize actually there's no value to the system because we're not monitoring the right things or we're not trying to change the right things. Obviously, the last thing is we mitigate that with our knowledge platform. We try to make sure we're aligned at the beginning. But other things that we do to help us with low adoption is we record lots of KPIs, and it's visible to the customer as well. So this is where we monitor the interaction of the tool by the user. So we can see how many cases are raised, how long does it take for a customer or a maintenance engineer to respond to that case and acknowledge it and deal with it. What's the ratio of good cases versus bad cases? And our sort of customer success team can interfere if we notice that customer is not adopting a system in the right way. So interfere before the pilot's over after 6 months. The second thing we surface are all the business outcomes. So you can see these business outcomes in the tool at any level, at the factory level or right down to a single machine. And the kind of KPIs that will automatically reveal, we have downtime avoided, you can see maybe it's relevant for you, carbon saved, maybe labour saved, maybe spare parts saved. And that surfaces all the time, so you can always see, are we getting value from the tool? Key for the CFO as well. Now the second thing that is probably has the worst reputation is over-alerting. A lot of condition monitoring systems and predictive maintenance systems bring so many alerts that it becomes useless. So I'm just going to ignore all that complicated stuff. I'm just going to focus on this. So I alluded to this before. So we have cases. Cases are our word for alerts, but cases are only raised if we're confident we've seen enough evidence from all the different types of things that might be going wrong that we're confident to raise a case. It's like a triage service, right? So you might get lots of anomalies thrown at the attention engine. That kind of goes around and decides at which point does my user want to be brought attention to this case, right? And for us, the average across all our customer base is for every 500 assets, 500 machines, we on average raise one case per day. So if you imagine your factory, you might have 500, 1,000, 2,000 machines, you're going to get 2 or 3 cases a day. So even if they were all wrong cases, they won't be, but even if they were, it's a low workload. And you'll get the users to respect that and are able to spend hours analyzing all the data. Now the last stage is what we call refine. That's basically your scaling, right? So you've done your pilot, it's successful because you knew it would be, because you did the scoping at the beginning. So at this point, you try to essentially cookie cutter what you've got, and can you then replicate that in other sites around the world, or maybe other lines within that one site? At this point, we check that the data quality was correct, if we're making changes. We check obviously that the business outcomes were achieved. If they weren't achieved, why not? Did we do something wrong to do that? And do those business outcomes also apply to the other sites? One site may have lots of old machines which serious downtime issues. Another site might be a nice new site, their issues over maintenance. So it might be different business outcomes that you want to achieve. So the issues that we see here for failure is a common one is, okay, it worked okay in the pilot, but the cost to scale this to all my lines is prohibitive because you ask me to spend, I don't know, £200 per machine to install a sensor. Or maybe it requires a huge amount of bespoke configuration or software development to get it to work. Sometimes, and I would say probably half the time, technology doesn't work. It's not fit for purpose. It's such a hyped up area. There's a lot of technology out there that's been branded as a predictive maintenance. That's a common failure, it doesn't work. And obviously at this point, you're scaling, and if you're still not clear of the business outcomes, you're not going to scale. Okay? So really be clear on what you're achieving there. So for us, how do we mitigate some of these issues of cost to scale, for example? And this is really the whole reason we set up Senseye 10 years ago, is we need to be able to really cover an entire factory, all the types of machines there. We need to be able to add machines and support new machine types automatically. If for every machine you've got to do some manual work, you've got to create a model, you've got to get some data samples in, you've got to do some complex configuration, it won't scale, it'll be too expensive. So the way to really make it scale is that any machine can be added to the system automatically. Right? And our customers self-serve. They add their own machines to the system without us being to help them. Right? So this allows us to go into a factory with 150 different types of machines and onboard them very quickly. Right? That's absolutely key, that we can automatically support these machines. The second one, and we've already talked about where we deployed this. If you go to the website, you can see some logos and things. But it's proven at scale. And I think if you're looking to deploy predictive maintenance, you bring a bunch of different vendors in, you ask them for a referenceable use case of, is it proven at scale? Not proven 10 machines, 20 machines, is it proven globally across multiple sites with thousands and thousands of machines, and does it give you an ROI? Right, so that's a key factor to look into. Just for information, our focus is mainly discrete industries, so automotive, food and beverage, but also we do some metals processing and things like that, so it's our sort of key sweet spot areas. So, as I said at the beginning, predictive maintenance is a journey of change. And hopefully the different steps that I've walked through show that it is lots of things that we need to do. It's not a technology that you just buy off the shelf and install. You're asking a lot of commitment from your own people, effort, momentum, sponsorship. And if we follow a process of deployment a process like this, the chance of success is a lot higher. But we still have failures. We're not 80%, but I would say 1 in 5 of our projects fails to scale. And almost always down to the business case not being strong enough. Or they say, actually, your tool is cool, and it works, and we have a problem with downtime, but actually it's cheaper for me to buy a hot standby and just have that next to it. Right, so you really need to be clear on the business outcomes. It's probably the number one lesson that we've learned over the years, and you often skip that and go straight to trying the cool technology. Okay, and I'll just leave you with the marketing slide at the end.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at siemens.com.